Okay, so have you ever walked into like a really brightly lit supermarket or maybe an office and you get that immediate, almost physical jolt?
Mm-hmm.
Like your eyes water, maybe your stomach clenches a bit, your whole system just kind of braces itself.
Yeah, that sensory hit.
Exactly. So what if that intense feeling isn't just you being, I don't know, fussy or anxious? What if it's actually like a physiological reality?
Well, that's exactly what we're digging into today. There's this really exciting, groundbreaking 2024 study, and it gives us the first direct experimental confirmation, in vivo, of something many autistic people have been describing for, well, decades.
Okay, so science is finally catching up to lived experience here.
That's a great way to put it, yeah. So in this deep dive, we're going to unpack this pretty dense neuroscience research, put it into plain language.
And reveal why, for so many people, the lights, literally are brighter.
Precisely. And explore what that really means.
Okay, let's unpack that initial sensory experience first. That idea of the world arriving too hard, too fast, too bright. Our sources, they really emphasize that for a lot of autistic individuals, these bright lights aren't just, visually intense. They describe them as metabolically expensive.
Right. Metabolically expensive. That really hits it, doesn't it? It's not just discomfort. It's like their system is constantly burning through energy reserves just to cope with that sensory input.
Like running a background process that's just draining the battery.
Exactly. Just being in a typically lit room can be exhausting. And this is where the study comes in. It's called Retinal GABAergic Alterations in Adults with Autism Spectrum Disorder. Huang and colleagues, 2024.
Okay, sounds technical.
Oh, it is. The official significance statement is definitely written for neuroscientists. Very dense. But buried in that technical language is something, well, honestly, quietly astonishing.
Astonishing how?
Because it provides clear, measurable scientific evidence for this lived experience that autistic people have been trying to explain for generations. It's measuring what they've been saying all along.
So how on earth did they measure something like that? Something so internal?
Well, they didn't just ask people how bright the light felt. They went right to the source, the eye itself.
Okay.
They used a technique called an electroretinogram, an ERG, think of it, kind of like an EKG for your heart. But this measures the eye.
An EKG for the eye. Okay, I can picture that.
Yeah, it measures the raw electrical activity of the retina, that light-sensitive layer at the back, right as it first receives light, before the signal even gets further into the brain.
So the very first reaction to light.
Exactly. And they were really careful about the light they used. It wasn't just flipping on a room light.
Right, you wouldn't want interference.
Precisely. They used a very specific, very controlled light stimulus. It was a precise mix of red, green, and blue light with 3 exact peaks in the spectrum. 470 nanometers for blue, 530 for green, 621 for red.
So like a really pure, balanced light.
Yeah, think clean, neutral almost, surgical. Nothing like the messy, spiky light from, say, fluorescent tubes or even many LEDs we encounter every day. They needed a baseline.
Okay, so they've got this controlled light. They're measuring the eye's first electrical zap. What do they find?
This is the kicker. Even with this super controlled neutral light, the autistic participants' retinas responded more strongly, significantly more strongly.
Really? Even at that first stage?
Yes. They looked at something called the A wave. That's basically the retina's very first electrical dip when light hits it. And for the autistic participants, this A wave was significantly larger, meaning the incoming light signal hit harder, electrically speaking, right from the very first stage of processing. Before the brain even gets deeply involved, the system's already amplifying the signal right at the front gate.
Wow. Okay, so it's not just perception. It's happening right in the eye.
That's what the data suggests. Then they did something else interesting. They introduced a drug called arbaclofen.
Arbaclofen. What does that do?
It acts on the GABA-B system. Now, GABA, generally speaking, is the brain's main inhibitory neurotransmitter. It's the calm down signal.
The brakes.
Kind of, yeah. The GABA-B system specifically acts like one of the nervous system's natural circuit breakers. It helps dampen down signals, preventing things from getting overwhelming.
Okay.
Now, it's really important to stress this specific form of arbaclofen, it's a research tool. It's not like a current treatment you can get. They used it here specifically to test what happens when you chemically boost those dampening mechanisms.
Got it. So they give this drug.
Yeah.
What happens to the eye's response?
Well, the results were pretty clear. For the autistic participants, taking arbaclofen decreased their retinal response. It brought it down closer to the levels seen in the non-autistic participants.
So boosting the brace actually calmed the eye's initial reaction.
It seems so, like the circuit breaker engaged more effectively.
And for the non-autistic participants?
For them, arbaclofen slightly increased their response, interestingly, but the effect was much smaller, less significant.
Okay, so let's try and piece this together. Autistic retinas respond more strongly to neutral light, and a drug that boosts the calming GABA system reduces that stronger response.
Exactly. So if you synthesize that, it strongly suggests that some aspects of sensory overload in autism might start really, really early, right at the point where light first enters the system. It could be related to differences in how these inhibitory systems, these circuit breakers, are functioning.
And they found this with that super clean neutral light.
Yes, and that's crucial, because think about real-world lighting. Fluorescent lights, harsh LEDs, our phone screens, they often have way more intense spikes, especially in the blue light range.
Which are often the ones people find most uncomfortable or draining.
Precisely. So if the system is already responding more intensely to neutral light, imagine what happens with the harsh, spiky light we live with daily. It's not just about raw brightness. It seems the control systems aren't buffering the signals in the same way.
So the signal gets through more forcefully.
Right. And that effort, that constant heightened response, that's likely part of what makes it so metabolically expensive, so draining.
Okay, this makes a lot of sense for visual sensitivity, but you hinted it might be broader. Why is this finding in the retina important beyond just, well, vision?
That's a great question, because the retina physiologically is actually brain tissue. It's an outpost of the central nervous system. So what happens there might reflect processes happening elsewhere.
Ah, yeah.
And the researchers didn't stop at the eye. They compared these retinal results with earlier data they had on how the same participants' brains responded to sounds.
Okay, different sense entirely.
Right, and they found a correlation. People who had those larger retinal responses to light also tended to show stronger brain responses to sound.
Wow, so the sensitivity isn't just in one place, it's showing up across different senses.
It suggests a more systemic pattern, yeah. The phenomenon isn't limited to vision.
And you mentioned GABA being this general calming system. So the same system involved in dampening the light signal in the retina, it's also working, or maybe working differently, with sounds, touch, other inputs.
That's the implication. The GABA system is crucial for regulating sensory inputs across the board: sounds, touches, smells, movement, you name it. If there are differences in how it functions, you'd expect to see effects in multiple sensory domains.
It's like the whole system's filter or volume control is set differently.
That's a good analogy. And there's another key correlation they found.
What's that?
The strength of these sensory responses, both the retinal response to light and the brain's response to sound, linked to broader autistic traits. Meaning, the more intense the measured sensory response, the higher that individual tended to score on standardized measures of autistic experience.
Okay, so this isn't just some isolated biological quirk. It connects directly to the core characteristics and experiences of autism.
Exactly. It suggests this pattern of sensory processing, this reduced filtering, maybe isn't just about sensitive eyes or ears. It seems to be a deeper, more fundamental aspect of how their entire nervous system interacts with the world.
The circuit breakers aren't tripping in the usual places, like you said.
Yeah. The signals just keep coming through, strong and clear, maybe too clear sometimes.
Which brings us right back to everyday life. Thinking about those specific triggers people talk about, fluorescent lights, that awful hum and flicker, the cold light.
Classic example.
Or the super harsh LED headlights you see now. Or just the intense blue-white brightness of our phone screens, especially at night.
Absolutely. For many autistic people, these aren't just minor annoyances. They are genuine triggers for overwhelm.
It's not just lighting up the room.
Yeah.
It feels like it's punching right into their system, doesn't it?
That's a powerful way to describe it, and it resonates with what many report. Which leads to a really important point about accommodations.
Okay.
When an autistic person asks for the lights to be dimmed, or maybe they wear tinted lenses indoors, it's really crucial to understand this isn't just about personal preference. It's not just comfort.
It's physiological.
It's a physiological accommodation. Based on findings like these, their sensory systems are processing that light differently right from the retina onwards. What feels neutral or even pleasant to one person can genuinely be painful, draining, or push someone towards shutdown or meltdown for another.
That makes sense of things like screen fatigue, too, maybe. It's not just your eyes getting tired from focusing.
Exactly. It could also be the sheer metabolic load of processing that constant, intense light input, especially the blue light. It's exhausting the system's ability to regulate itself.
Which is why things like blue light filtering glasses or screen filters can be so helpful for some people.
They're often a really functional strategy. It's not about fashion or a fad. It's about reducing that constant sensory assault, easing the metabolic drain so they can, function better throughout the day.
This brings up something else mentioned in the source material. The politics of measurement. What's that about?
Ah, yeah. That's a really critical point. The thing is, autistic people have been describing these experiences, the pain from light, the overwhelm, the exhaustion, for decades, generations even.
Right. This isn't new information to them.
Not at all. The pain didn't suddenly become real because a scientist finally pointed an electrode at a retina,
Good point.
What studies like this do is provide the type of objective data that sometimes, unfortunately, is needed to convince policymakers, educators, occupational health teams, people who might have previously dismissed verbal accounts or subjective experiences.
So the study catches the science up to the lived reality. It gives people a tool.
Exactly, a tool for advocacy.
Yeah.
It's not about legitimizing the experience. The experience was always legitimate.
Yeah.
It's about providing evidence in a language that certain systems understand and, frankly, demand.
So this validation is huge. It gives autistic people language, maybe backup, to explain their needs. But what about for non-autistic people? Parents, teachers, employers, clinicians?
For them, it's hopefully a real clarification. It underscores that request for things like dimmer lighting, different types of bulbs, permission to wear tinted glasses. These aren't luxuries. It's not about being difficult.
It's basic access, like a wheelchair ramp for someone with mobility issues.
That's a great comparison. It's about creating environments where everyone can function without being actively harmed or depleted by the sensory environment. It's understanding that when someone describes a sensory experience, even if it's different from your own, it's real for them.
The source material even suggested a sort of sample statement people could use, right?
Yes, it's quite powerful. Something along the lines of, as an autistic person, I experience sensory processing differences that can make certain kinds of lighting physically painful and exhausting.
Straightforward.
And then adding, this isn't simply a matter of comfort or preference, it's part of how my nervous system processes incoming sensory information. And now you can even add that recent studies, like Huang et al., confirm differences right down to the retinal level.
So adjustments like dimmer switches or wearing specific lenses aren't just wants.
They're physiological strategies to reduce harm. That's the key framing. And honestly, the ultimate message is about solidarity. Believe people. Offer the accommodation. We shouldn't need a peer-reviewed study to justify basic human decency and access, right? But now, for those who felt they needed it, the data is starting to arrive.
So we come full circle. Back to that feeling in the bright supermarket. For so many people, the reality of that sensory overload, that pain, that exhaustion, it was never in doubt.
Never. They've lived it. They've developed strategies, coping mechanisms, ways to manage, ways to mask, often without understanding or validation from the outside world.
The headaches, the fatigue, that quiet dread of knowing you have to go into a brightly lit space.
All part of it.
So the science is catching up. The measuring devices are confirming what people knew in their bones.
Yes. The data now exists in a format science recognizes. But the truth, that was always there, in the lived experience, in people's bodies, in their words.
Which leaves us with a thought, maybe.
Perhaps this, especially if you're non-autistic, listen sooner next time. Trust the expert in the room, the person living the experience. Don't wait for the machines, for the graphs, for the p-values.
They knew.
They knew. Now you can measure it too. The lights were always brighter for them.